Hello everyone. Welcome back to this lecture series on engineering mechanics. See, up to the previous lecture, we have been discussing about the variation in the behavior of objects which are in rest condition, that is static condition. Now we are moving on to the next level wherein the objects are in motion, that is dynamic condition we are going to see. So this dynamic condition has been broadly classified into two things. One is kinematics and the other one is kinetics. So here in the kinematics, we will be studying the change in behavior of objects which are in motion, but we will not be considering the force that causes the motion. Whereas in kinetics, we will consider the force that causes the motion. So coming on to this kinematics, it's been divided into two things. Depends on the direction of the motion. If the objects are moving in a straight line path, it is called rectilinear motion. And the second one is, if the objects are moved in a curved path, it is called curvilinear motion. Under the rectilinear motion itself, we have two different conditions are available. One is the object moves with a constant acceleration and the other one is moving with a variable acceleration. Let us start with this lecture number 29, wherein we are going to discuss the applications of the constant acceleration condition. As we know that the equations of motion is being defined with three different equations. One is v is equal to u plus at. Second one is s is equal to ut plus half at square. And the third one is v square is equal to u square plus 2as. If there is any initial condition that we will have an expanded equation as s is equal to s naught plus ut plus half at square. Similarly, v square is equal to u square plus 2a into s minus s naught. And regarding the dynamic properties, we'll be discussing about the displacement, velocity as well as the acceleration in terms of any time intervals. So with this basic introduction, we'll move on with the applications of this, the rectilinear motion and the constant acceleration condition. Now start off with this one. We have a motorist is traveling a car at 54 km per hour. Once she is driving, she observed a traffic light is available at a distance of 240 meters and it was observed to be in a red color. So the timing has been mentioned as 24 seconds for which the red to be converted into green. So this driver trying to reduce the speed of the vehicle in such a way that she is not planning to stop the vehicle at the junction of the signal. So she is going to reduce the speed in such a way that once she reaches the signal point, that is 24 seconds, she has to reach the signal point within exactly 24 seconds, so that she will not make the speed to become zero. Thereafter, she will be increasing the acceleration. That is what the condition. So we are supposed to find the required uniform deceleration. Deceleration in the sense minus acceleration. And the speed of the car as it passes the light. Okay. So we have the initial velocity, that is the speed has been given as 54 km per hour. That has to be converted in terms of meter per second, that is 15 meter per second. Now applying the equation s is equal to ut plus half at square, we will have initial velocity is 15 meter per second. Time taken to reach that particular point is 24 seconds. Acceleration is unknown and the time is 24. So substituting everything, we are getting the acceleration as minus 0.4167 meter per second square. So since negative value, it means that the acceleration is becoming negative, that is deceleration of the car is taking place. So that is what is the first question. Second question is we need to find the speed of the car as it passes the light. That is at that particular segment, what is the final velocity? So v is equal to u plus at. So here u is 15, a is calculated as minus 0.4167 and the time required is 24 seconds. So substituting everything, we are getting the velocity. Final velocity is 5 meter per second. But again, the initial speed has been given in terms of kilometer per hour. Therefore, the final speed also should be mentioned in terms of kilometer per hour. So converting that one, we are getting the final speed as 18 kilometer per hour. Moving on with the second example, in which a 100-meter dash has been given. A sprinter is taking 5.4 seconds to reach the first segment of 35 meter, wherein he is increasing its acceleration uniformly. Then after reaching 35 meter, is going to maintain the acceleration until the end of the race. You are supposed to find out the acceleration, the final velocity, as well as the time for the race. Normally in any 100-meter dasher, the sprinter will start the racer with its maximum effectiveness so that he can reach its own maximum limit. Then thereafter, he'll try to maintain its acceleration until the end of the race. That's what has been given. So we'll have two segments are there. One is increasing his acceleration uniformly to reach the 35 meter. Then thereafter, he is maintaining the constant velocity. Okay. So starting with the segment 1, we have S is equal to 35 meter and initial velocity is 0, time is 5.4 seconds. So using which S is equal to ut plus half at square, we'll get the acceleration. Other terms are no. Right. So substituting everything, u is 0 and then t is 5.4 seconds, S is 35 meter. So solving this one, we are getting the acceleration 2.4 meter per second square. So the first one is over. Second one is we need to find out is final velocity. That is, this can be even find out in the first segment itself, because second segment is going to maintain the same velocity. So v is equal to u plus at, in which u is 0. A is being calculated as 2.4 and t is 5.4 seconds. Substituting this one, we are getting the final velocity as 12.96 meter per second. So that is being calculated. Now moving on with the second segment, in which the distance to be covered is 65 meter. Okay, and he is going to maintain the uniform velocity, thereby the acceleration is 0 for this segment. Okay, so substituting S is equal to ut plus half at square, in which A is 0, therefore S is equal to ut alone will be that. So 65 meter is the second segment, 12.96 is the velocity, and t2 is the time taken for this covering the second segment of the race. So solving this one, we are getting the time required for the second segment, that is 65 meter, is being calculated as 5.02 seconds. So already the first segment time has been given. Therefore, this time taken by the sprinter to complete his own race is T1 plus T2. That is 5.4 seconds plus 5.02 seconds. We are getting 10.42 seconds. So moving on with the third numerical, in which a package starts from rest, which passes over a skate wheel conveyor ABCD in 3 different directions. So one is the segment AB, in which we have the data as u is equal to 0 because it starts from rest. And it's going to be traveling with the acceleration, uniform acceleration of 4.8 meter per second square. Right. So we need to find the time required for this first segment. Coming on to the second segment, is going to maintain the velocity constant between B and C. Velocity is constant between B and C. So for the first segment, we need to calculate V1 also. That is VAB. So that velocity will be constant in this case. Whatever the velocity we are calculating, this is what the velocity for this segment also. So we need to calculate T2 alone in this segment. And moving on with the third segment, we have the velocity that VAB will be the initial velocity for this segment, and the final velocity at the point D has been given as 7.2 meter per second. And during this segment also, the package is going to maintain the uniform acceleration of 4.8 meter per second square as it moves down the section AB as well as CD. Okay, so we need to calculate this distance as well as T3 also to be calculated. Why T1, T2, T3 has to be calculated is that is the second part of the question. That is the total time to be calculated. T1 plus T2 plus T3 to be calculated. Right. Let us move with the first segment AB. And we know we have U is equal to 0 in this segment. U is equal to 0. S is equal to 3. And A is equal to 4.8. Okay, so using this one, we are calculating V square is equal to U square plus 2AS for the segment AB. Since U is equal to 0, VAB square will be equal to 2A SAB. Right. So substituting that values 2 into 4.8 into 3, we are getting the VAB value as 5.37 meter per second. Okay. So this is what the velocity that we calculated here, and they are going to maintain this velocity over this segment. Okay, VAB, which will be equal to VBC also. Sorry. VBC also, sorry. And one more thing that we need to find out the time also, T1 also to be calculated. Therefore, we are using V is equal to U plus AT, in which U is 0, V has been calculated 5.37, A is being given as 4.8. Therefore, TAB can be calculated as 1.12 seconds. So that is what with respect to segment AB. Let us move with the segment BC. So segment BC, we have uniform velocity, that is V is equal to what is that one, 5.37 meter per second, and is going to maintain the constant speed. Therefore, A is equal to 0 and D is being given as 3 meter. Okay, so using this one, we are supposed to calculate T alone for this segment. So S is equal to UD plus half AT square, and the distance is 3 meter. Velocity is to be maintained constant. Therefore, this component will become 0. Okay, therefore 3 will be equal to 5.37 into TBC. Solving this one, we are getting the TBC as 0.56 seconds. That's all with respect to the second segment. Let us move with the third segment, CD. So for the segment CD, the initial velocity is the velocity for the segment BC, that is nothing like 5.37. Second one is the acceleration is given, that is 4.8. Final velocity is also being given 7.2. Right. So we are supposed to calculate a D as well as T3. This is what we need to calculate. For this case, we need to find out T2 alone. Okay. So again, V square is equal to U square plus 2AS, in which U is 5.37, acceleration is 4.8, and the final velocity is 7.2. Substituting everything, we are getting the D value, that is nothing like the S. Okay. So D can be calculated as 2.4 meter. That's what is the first question. And the next one is we need to find the time taken by the package to travel this segment CD. Okay, T3. So B is equal to U plus AT, we are substituting, and we are getting the TCD as 0.38 seconds. Okay. So first question is we calculated D. The second question is we need to find the total time required by the package to reach the point D. That is, total time required will be TAB plus TBC plus TCD. So adding up all these things, 1, 2 as well as this 3, we are getting the total time required is 2.06 seconds. Now moving on with the final example of this lecture, in which two trains A and B leave the same station on parallel lines. Train A starts with a uniform acceleration of 0.15 meter square and attains a speed of 24 km per hour when the steam is required to keep speed constant. Whereas train B leaves 40 seconds after the train A with a uniform acceleration of 0.3 meter per second square to attain a maximum speed of 48 km per hour. Question is, when will the train B overtake train A? So we have two trains are there, both are starting from the same station but not at the same time. Okay, it's something like a relative motion. So train A, this starts at an acceleration of 0.15 meters per second square and it's going to attain a speed of 24 km per hour. Then thereafter, it's going to maintain the speed constant. Whereas train B starts 40 seconds later with an acceleration of 0.3 meter per second square in order to reach a maximum speed of 48 km per hour, and then thereafter is going to maintain the constant speed. So question is, when the train B will overtake train A. So for both the trains, we have two segments are there. First segment is from 0 to reaching a maximum speed. Then the second segment is maintaining the constant speed. Okay. So again, the velocity is being given as kilometer per hour, converting everything in terms of meter per second. Train A having an initial velocity speed of 6.67 meter per second, whereas the train B is having 13.33 meter per second. Let us start with the train A. Let T1 be the time taken by train A to reach its speed 24 km per hour, that is 6.67 meter per second. So we have V is equal to U plus AT, right? So in which V is 24 km per hour or otherwise 6.67 meter per second. It's going to start from rest, therefore u is equal to 0. Acceleration is given as 0.15 meter per second square. So from which t can be calculated. So t1 is 4.44 seconds. So train A takes 4.44 seconds to reach its maximum speed of 24 km per hour. Okay. Then for this duration of 4.44 seconds, in order to reach its maximum speed, train A traveled a distance of that is s is equal to ud plus half ad square, in which u is 0. Substituting the acceleration as well as the time taken, we are getting that the distance traveled by train A is 148 meter. Now let us move with the train B for the same first segment. Let again T2 be the time taken by train B to reach its maximum speed of 13.33 meter per second. Okay, again substituting the same relation, V is equal to u plus at, in which V is 13.33, u is 0. Acceleration is given as how much it is? 0.3 meter per second square. So substituting, we are getting the T2, that is the time taken by the train B to reach its own maximum speed of 13.33 meter per second is 4.44 seconds. Again, both are identical in terms of time. Whereas the distance covered by the train B for traveling a distance of, duration of 4.44 seconds will be 296 meter, double the distance traveled by the train A. Okay. Why means it is having the double the acceleration. Right. So this is with respect to the first segment. Then the second segment is it's going to maintain the speed constant. Both the trains going to maintain the constant speed. Let train B overtake train A when they covered a distance s from the start. It is the total distance, not only the first segment or the second segment. It is the total distance at which the train B will overtake the train A. Also, train B take t seconds to overtake train A. Again, this is also for the whole distance, not for segmental duration. Now, the time taken by train A to cover the distance S will be t plus 40 seconds because train A started 40 seconds earlier. Okay. Since it is moving very slowly to attain that particular point where train B is overtaking train A, therefore the time taken by train A will be t plus 40 seconds. So the total distance traveled by train A is the distance traveled in order to attain its maximum speed plus the distance covered with a constant speed. So already this has been calculated, that is 148 meter in order to attain its maximum speed, and then the distance covered with a constant speed. Therefore, substituting this one, we are getting S is equal to 148 plus distance covered with a constant speed, that is ut alone will be there, in which u is being given as 6.67 meter per second, that is 24 km per hour. Right. T is the total distance time taken by the train A is t plus 40 seconds, whereas for the first segment, it has already taken t1 time duration. So that has to be deducted. That is why t plus 40 minus t1. And the t1 has been already calculated, which is 4.44 seconds. So substituting that one, we are getting the distance covered by the train A at which train B will be overtaking us is 148 plus t minus 44.44 into 6.67. Actually, this has to be checked. It's not 44.44. So it should be 40 minus 44.44. Therefore, it should be t minus 4.44 into 6.67. Okay. Similarly, going with the train B, it is covering a distance 296 wherein t2 will be equal to again 4.44 seconds plus distance covered with the constant speed, that is ut. So S is equal to ut plus here t is the time taken by the train B, that's what we assumed. So t minus t2, that is time taken for the first segment, into its own velocity of 13.33. So substituting this one, we are getting that value as t is, what is that one, t minus 44.44. 44.44 again. right? So equating these two, that is this one and this one, because S is constant on both the sides, equating this one, that is again, this is 4.44, right? So we are getting the time taken by the train B to overtake train A will be 62.26 seconds. This is what has been asked. When train B will overtake train A, that is T has to be calculated. If the question is extended to when and where in the sense, substitute the value of T in any of these equations in order to get the S value also. Okay. So with this, we are completing this lecture. In the next lecture, we will move on with the variable acceleration in the horizontal path under rectilinear motion. Thank you.